Hello again, everyone. Now today, as well as having a little recap, what we're going to do is move on to our second lesson. I'm going to cover some things about ions, and they're in brackets because I'm not going to spend a lot of time on them. It's something you just need to sit down and you'll understand more as the year goes on. But certainly give you a skeleton for carbohydrates. Now there's lots of detail, hits you very hard and fast when we start back, but I'll start building it into this. Okay, up here we've got a boomerang. Anybody remember what the boomerang was for? Good. Water. So this is what the first wee video went through. Set of molecules. We're going to cover 6 key components. In the water, we went through some key issues relating to water, being down here. The idea that water molecules are polar, meaning they have positive bits and negative bits. Because of that polar nature, we get hydrogen bonds forming between them, which makes the water molecules, and technically it is called being sticky, but similar molecules sticking together is called cohesion. Molecules sticking to something that's different is called adhesion, hence the derivative of the word adhesive. And sorry, I didn't mean to put this up. This would be what the notes are like. So there's wee bits explaining the hydrogen bonds will be going on there, and the whole idea of cohesion, and the idea that it is polar. There'll be a wee QR code. Feel free, freeze the video. If you have 2 devices, you could do that, but I'll put up the notes. And here's a good thing. Why is it so important that water's polar? It makes it a very good solvent. Now, solvent, remember, is a liquid into which things dissolve. And that makes it super, certainly in our bodies, for transport, in our plasma, and also transporting plants. 2 keywords now, the jam just down the bottom, and it makes them look like they're very insignificant. And they are hydrophilic and hydrophobic. So the first bit of both words is hydro, and obviously that sounds like it is to do with water. You maybe have heard of hydrolysis, maybe at GCSE chemistry. We'll meet it later on this year. You've heard of phobic before, or phobia. So if you've got a fear of something, it's called phobia. So if this one means, sorry, get the pointer. If hydro means water, phobic means fear, this is water fearing, and the philic means attracting. And I don't know whether you've ever played or had as a child moon sand, as they called it. It was this sort of granular stuff you put in water and you could make wee shapes. It certainly was hydrophobic, so it was water repelling. So just for now, anything that's hydrophilic dissolves in water, it's attracted to water. Non-polar substances, in other words, they don't carry the similar charges just like water, are hydrophobic. And basically they repel water, don't dissolve. Some examples of where water is an important solvent is, as mentioned, plasma in your blood, where it carries the dissolved glucose and minerals and ions around. Urine, which is basically a liquid in which we get urea and ammonium dissolved in it. And then within plants, to transport the sugar produced in photosynthesis, it goes in a liquid medium through phloem you'll meet later on. So the ions, the only thing to remember here, and certainly I would do in my classes, to make sure they can know that there's 1, 2, 3, 4, 5, 6, 7 ions they need to remember, and I get them to make a wee rhyme up, trying to recall something. But the way I've put it out is you need to know an example in plants and animals. That's a very common one, frequently asked in exams. Magnesium in plants, chlorophyll, and you maybe didn't know bones and teeth in ourselves. Another very common one is calcium. Now some of you could tell me about from GCSE being involved in cell walls, but the A level is that calcium pectate. We have 2 plant cells, so there's a wee plant cell, and we know we draw the cell wall with a double line. There's another wee plant cell, take a lazy way of doing it. For those 2 to stick together, there's actually, it's literally like a glue put down in between them. So in between those two cell walls, there'll be a bit of glue smeared. And that's this stuff called calcium pectate. So we'll go through that next year, but it is a matter of just going through and learning. Later on when we study nucleic acids, then you'll see where phosphate comes from. And you know, nitrate contains nitrogen, and we'll learn about that all to do with protein. So you do pick this up as you go along. A key word maybe just at the beginning is the word buffer. I don't know what GCSE chemistry you meet it. A buffer, it just maintains pH. And we know from GCSE that pH affects enzymes. So this is very much, don't panic. Again, if I remember, I'll put this page up and the previous page. You can have a wee read through. So on to something familiar, but trying to stretch it to something new. If you had a wee piece of paper beside you and I said to you, please write down the elements that comprise carbohydrates, you would say, correct? You would say carbon, hydrogen, and oxygen. Now, there are 3 classes of carbohydrates that we need to go about learning. There are what are known as monosaccharides, disaccharides, and poly. They all differ in the prefix, the start. Saccharide literally translates as sugar. So mono, you would say that means single sugar. Di mean double sugar, and poly just means many. Okay, so let's just take those bits off to keep it neat. Monosaccharides, you should certainly know one of these from GCSE. That is glucose. And again, if I went down here and said to you, please tell me the elements present, you would hopefully say, yep, again, it's carbon, because we know it's hydrogen, it's oxygen. If I ask you the chemical formula, good, C6H12O6. That is glucose. Fructose, you mightn't have heard of. Fructose you would find in, guess what it is? Yep, that's in fruit, basically. By the way, that's an apple. In fruit, and makes the fruit taste sweet. Fructose also has CHO and also has C6H12O6. They have exactly the same chemical formula, but it's arranged differently. So they are different shapes. It'd be like me giving you 6 red Lego bricks, 12 yellow, and 6 blue. Everybody might arrange them slightly differently. They'd have the same numbers of the same colours, but you put them together differently, you get different things. So for monosaccharides at this moment, I want you to remember they're single sugars. There are 2 examples. Now the more detail is going to come with the glucose. 2 examples, glucose and fructose, and they're both C6H12O6. Just when we're here, to help you remember what they look like, if I was to draw a wee fish, so there's a wee fish, there's its wee eye. I know fish don't breathe bubbles, but can you imagine that's a fish? So mouth, the eye, fin, and the tail. That's the easiest way to draw a monosaccharide, except obviously it doesn't have a wee dot on its eye there. It has an oxygen molecule, and obviously it doesn't have all those wee things. A disaccharide is literally where you take two of these and basically you join them together somehow and you make a molecule where 2 of them are bonded together. Now I'm not going to do the bonding with you now, but that's what it is. So they're double sugars, 2 single sugars, joined together. 2 named examples that you need to know are maltose and sucrose. Now, sucrose is your table sugar. So the only place sugar should go is on your 4 Weetabix with sugar, nothing else. So don't be a sado and put sugar on sugar puffs or crunchy cornflakes or anything. So your table sugar is sucrose. So a little learner for today is maltose. If I take glucose, a single sugar, and join it onto a glucose, that equals maltose. If I take glucose and join it onto this one here, fructose, I get sucrose. Okay, so there's a lot of learning on this page. Go to polysaccharides. Now, in fact, all of those you should be familiar with. Starch is a storage carbohydrate found in plants. Glycogen is a storage carbohydrate found in animals. And here's a weird one, also in fungi. Fungi like mushrooms and toadstools and yeast, etc. Cellulose is found in plants, but this is an energy store. This is obviously, yeah, well done, the cell wall. So it's a structural role. And because of their different roles, they've got different arrangements of molecules. So we have monosaccharides, disaccharides, and polysaccharides. So if you can learn this page, if you could recall this as it sits here, the elements present, the number in each, tag that onto fructose, say it's what makes apples taste sweet. Now if you take 2 single sugars joined together, you have 2 options, maltose and glucose. If it's 2 similar glucose molecules together, you make maltose. If it's glucose and fructose, you make sucrose. Okay, the way I remember it is that has a U in it, so does that. Okay, it doesn't always work because so does glucose, but I don't even remember that. So if you put that, it works in my head. So if you can come up with some mechanism, work at it. Okay, so run over that, even start a little mini translation log, and that will go a long, long way to making your start of next year far easier. Thank you for listening.